one thing we do want to know about in a value stream map, we want to know what the lead time is, and it's going to be, measured over a number of products or orders, and there's going to be an average taken, right? So there's going to be variation again, right? But you're going to want to have an average lead time. You want to know what the WIP is in the process and the WIP at various stages, what the work in progress that started but not finished is at different places in the process. You could call it, internal inventory. You also want to know inventory on the supplier side and on the finished goods side, but work in progress is very important. And then throughput, which is the inverse of end of line cycle time, right? When it's coming off the line at a certain rate, that is your throughput, and the time between consecutive deliveries is your cycle time. And so those things. Now, Kingman's law also says utilization is very important. So what is utilization for a workstation or for a nurse or for an oven, right? Anything. What's the utilization? Well, it's to do with value added time and non-value added time. It's about availability of the unit to be actually doing the work and how much of that time is actually successful in producing good products. So you might see it as VA, NVA on the value stream map. But what we're trying to actually show is what is the utilization, because utilization is very good and very important. And unlike the conventional wisdom would be to say, as close to 100% utilization is good, is best. But in fact, from Kingman's law, that's not good, because it won't allow then for any variation.
Yep.
So a bit less, maybe 80 to, it depends on the situation, but not 100% would be the right utilization. The processing time obviously has an effect on queue length, right? So the longer it takes to process something, the cycle time, if you like, then the more likely that if you have a supply coming to that processing unit, it's going to build up a queue. So processing time, we might call that cycle time. And the other component was variation. So very, very important is to know what is the variation in your process. So what are we expecting in terms of the feed speed, or the supply side variation? What is the variation in the cycle time or the processing time, right? As we call processing time. So are we going to be using standard deviation for that measure? Are we going to be using range, interquartile range? It sometimes depends on what is the profile or the statistical distribution profile of it, whether you can use standard deviation effectively, and the less normal it is, then standard deviation becomes more problematical, and you might want to use some other measure of standard variation. And you and I both know that a lot of engineers out there just they know normal distribution, they know mean, and they know standard deviation, and they just apply that to everything, irrespective of the actual distribution. So that can be very misleading. And I hope your software will allow for that. You can put in like the Monte Carlo simulation. You can say what is the profile of the distribution. Is it triangular? Is it rectangular? Is it log normal, Gaussian?
Yeah. One thing that SVEND didn't lose in its kind of rebranding growing up was the statistics workbench that it came with the first time around. So everything that it kind of shipped with the first time around is still there, with one big exception, that in the process of, again, splitting things out, we actually took the statistical tests and things that were kind of baked into it before and built a whole calibration suite for them against, NIST. So kind of the standard, data sets from NIST, the Minitab,
very good.
Worked examples, and then our standard libraries, which are right now, just because they're documented, with, academic papers, kind of the accepted, standard for, output. And I think I sent you the NIST standard calibration, but we try to do that within, for the ones that matter, within, 1/1 billionth of a decimal place tolerance. So we didn't lose any of that in all of this. So all of that capability still exists. It's just how it's sort of built into the VSM side of it is a bit more rational than it was before.